All right, today we're pulling back the curtain on one of the internet's greatest unsung heroes. It's a technology you use every single second you're online, but you've probably never seen it. We're talking about Network Address Translation, or NAT. It's the clever trick that keeps the modern internet from completely falling apart.
I mean, just think about your house right now. You've got your phone, your laptop, maybe a smart TV, a tablet. All of them are online, all at the same time through one single Wi-Fi router. So how in the world does that little box juggle all of those conversations without getting everything mixed up? That's the exact question we're going to answer right now.
But to really understand why NAT is so brilliant, we first need to understand the problem it was built to solve. And it was a huge problem. Back in the early days, the internet was facing a massive crisis, a ticking time bomb, really. It was running out of room.
And here's the core of that problem. On one side, you've got your private network, your home, your office, where all your devices use these private IP addresses. And these aren't special. Your laptop could have the exact same 192.168 address as your neighbor's. But on the other side, out on the public internet, every single connection needs a globally unique public IP address to be found. With billions of devices coming online and only about 4 billion addresses available in the old system, well, you do the math. We were running out of addresses fast.
So what do? How do you connect all those private devices to a public internet that's run out of space? Well, this is where our hero, NAT, comes onto the scene. It's the great translator that sits right in the middle, bridging these two completely different worlds.
So what is it really? At its heart, NAT is just a process that lives on your router. Its main job is to play a little game of switcheroo. It takes a data packet from your computer, looks at the private from address, and swaps it out for your router's single public IP address before sending it on its way. It's all happening at what network folks call Layer 3, the part of the data packet that deals with IP addresses.
You know, my favorite way to think about this is to imagine a big office building. The whole company has just one main phone number, right? That's the public number. But inside, there are hundreds of employees, each with their own personal extension. The receptionist is the magic. A call comes in and they know exactly who it's for and where to send it. Your router, running NAT, is that brilliant receptionist for all your internet traffic.
And this is something you can totally see for yourself. If you check your computer's network settings, you'll see its private IP. But then, if you open a web browser and just Google, "What is my IP address?" you'll see a completely different number. That's your public IP. That's the address of your router, the single face your entire network shows to the world. And it's all because of NAT.
Okay, so NAT isn't a one-size-fits-all solution. There are actually a few different flavors, so to speak. So let's quickly explore the main types to see how this idea evolved.
The two big styles are static and dynamic. Static NAT is like having a reserved parking spot. One private IP address is permanently married to one public IP address. It's a direct one-to-one link, always there. Dynamic NAT, on the other hand, is more like a public parking garage. You have a pool of public IP addresses, and as your devices need to go online, they just grab the first available one. But if the garage is full, well, the next car has to wait.
But honestly, those two are just the opening act. The real star of the show, the absolute superstar that you are using right this very second, is a special kind of dynamic NAT called PAT.
PAT stands for Port Address Translation, and this is where the real magic happens. It doesn't just translate the IP address, it also keeps track of something called a port number for every single conversation. And that's the game changer. By using thousands of these different port numbers, PAT allows one single public IP address to juggle conversations for hundreds of private devices all at the same time.
So let's walk through it. 1. Your laptop sends out a request to a website. 2. Your router intercepts it, swaps the private IP for its public one, and assigns a unique port number to this specific conversation. 3, and this is crucial, it writes this pairing down in a little logbook. 4, when the website replies, it sends data back to the router's public IP and that specific port. And 5, the router just looks at its logbook, sees that port number, and says, "Ah, that's for the laptop," and forwards the data to the right device. It does this millions of times a day for all your gadgets. It's incredible. So that's the theory. But what does this actually look like when a network engineer is typing away configuring a router in the real world? Let's take a quick peek behind the curtain and learn the language. Now, before we see the commands, you just got to know 4 key terms. Inside local, that's simple. It's your computer's private IP. Inside global, that's the public IP the rest of the world sees. So, your router's IP. Outside global is the public IP of the server you're trying to reach, like Google.
And outside local, well, you pretty much never see that one, so don't worry about it. Knowing those first three makes the rest a piece of cake.
All right, check this out. For a static NAT, the command is exactly what you'd expect. The keyword is static. You are literally telling the router to create a permanent, static link between this one private address and this one public address. Simple as that.
Next up, Dynamic NAT. Remember the keyword we used? The parking garage analogy? It was pool. And there it is, right in the command. You create a pool of public addresses, and then you just tell the router to let your inside devices borrow an address from that pool when they need one. And now for the most common one, PAT. Look closely at this command. It looks almost identical to the Dynamic NAT command, but with one tiny magic word added to the end, overload. That's it. That one word tells the router, hey, take that pool of addresses, even if it's just one IP, and overload it. Use the port numbers to handle everything. So much power packed into that one little word.
So at the end of the day, NAT was a truly genius fix. It saved the internet from a catastrophic address shortage decades ago and allowed it to grow into what it is today. But it was always a workaround, a patch on a bigger problem. And that leaves us with a pretty big question to think about. As we move into a future with trillions of connected devices, is this clever fix from the 90s really the right foundation for the internet of tomorrow?